Hello, I'm Dr. Paul, and we're going to continue our series on evaluating the quality of the test. We are not evaluating the quality of the subject or client or patient who performed the test. We're evaluating our quality. How did we test? Were there issues during the test? There may have been limitations by the patient that affected the test. And this particular video is about, was there an anaerobic threshold reached during the test? So let's just jump into that now, because the anaerobic threshold will later on give us data for interpretation that could be useful for medical conditions and definitely useful for athletes who are seeking to gain greater endurance and power for their competitions. So we're going to close that out, and we're going to jump up here real quick and take a look at what we got here. So we had set up, if you remember, a way to evaluate the test under 5 different headings: the length of the test, the heart rate slope, the RER, what level did it reach, did we reach an anaerobic threshold, number 4, and then number 5 we'll look at heart rate recovery. All of these are kind of key components to interpret in the test, to use it for exercise prescription or medical evaluation. So what is the anaerobic threshold? How do we see it on a test? Well, the anaerobic threshold is really when we have the oxygen, the O2 here, and it continues to rise, and there continues to be a good supply of it. And then we also see alongside of it is the carbon dioxide, the CO2, and it's rising. And an anaerobic threshold is when the CO2 eclipses the O2, where you begin to produce much more CO2, or you start to produce much more CO2 than you are able to extract O2. Now here we see a cross, but this cross happens at the end of the test, so this is not a true anaerobic threshold. So let's look at some other slides we have here. We'll see that there's the CO2 in the blue coming up. So you see that CO2 coming up in the blue. We see the O2 coming up in the green. We never see them cross. And so when you see that, that they don't cross each other, or the CO2 does not eclipse the O2, you'll notice over here at the AT that it's 58.4, and also the peak is 58.4. That's a good sign that they didn't really reach a true anaerobic threshold. Usually there's a differentiation between these two, but not on this test. So there was no anaerobic threshold here. This particular patient is an athlete, and she was absolutely amazing. Let's move to the next one. Okay, so we can watch the CO2 coming up, and we do see an actual cross right here. We see where the CO2 eclipses the O2, and now we can say we have an anaerobic threshold. If you remember the previous video, when we talked about the RER, we've seen that it was CO2 divided by O2. It was when the CO2 became greater or produced more than the O2 was able to extract. And we see that here, and we could maybe put that AT right on this line, somewhere around 24. And if we look over here, we see it's at 24. We also see it continue to go on and plateau, and we see the CO2 continues to climb as it goes. And then if we look at the peak, we see it's 26.9, the VO2, and the AT is 24.1. So that's a good sign that we know that an AT has been reached here, an anaerobic threshold. This is when they moved from aerobic exercise, which is the use of oxygen, to the anaerobic, which is a chemical way to create energy. So that's a good sign. Let's look at another one. We look at this test and we see the CO2 coming up, coming up, coming up, and we see it cross over right there. Somewhere in here, maybe at the line 42, we come over here, it's 40.6. And then we kind of see it after it even climbs over, we see it goes up and the CO2 goes even higher, and we see there's a peak of 46. So we do see a difference here, and we see it cross over here. So this would definitely get a point in our test system, just like this previous one crossed over, definitely gets a point. The anaerobic was detected in both of those. This particular one, they don't get a point. There was no anaerobic threshold detected. So let's see if we have one more. Okay, so we got another one, and we see kind of the same parallel issue. We never see the CO2 eclipse the O2. There's no real anaerobic threshold here. If we look at these, we see the numbers are the same, so we know that wasn't really in. So this test would get a 0. And then we look at this particular one, and we see this the CO2 line back up, comes, and we see it crosses right in here somewhere. Somewhere it looks like around, I don't know, 21, and it's at 21.6. The test continues past that, and we see that there was a peak of 24. So we see clear difference there, and we can see it right here. Anaerobic threshold was reached, so the test gets a point on that one. Here we look at another test, and again we see the CO2 coming up. Eclipses very early on in this test, actually 2 minutes and 45 seconds it's eclipsed, and it continues to climb and rise. And so if we look over here, we kind of follow this line over to 20. Looks like it picked up at 18.7, and his VO2 actually came up to 26. So you can see that. So going back again to our scoring, we would want to be able to score tests where there is a clear anaerobic threshold reached, adding that 1 point. All right, I think that's good. One other thing I would like to show you is, let's jump onto Cardio Coach real quick. If we look at this test, we can see that there was a crossover right here, somewhere again around 19 or 20. We look at the test results, 19.6, and there was a VO2 of 20.5. So it looks like there's an anaerobic threshold reached here, gets a point. This is also seen, the anaerobic threshold can also be seen here in the second panel of our 8 panels, where we see it cross here. Of course, the angle is inverted from the previous panel, but you see a crossover right here, and of course the anaerobic threshold, which is this line for anaerobic threshold, is marked here, the blue one being aerobic. And then we can almost see it again here. This is typically how Korr software marks the anaerobic threshold, is when there's a crossover 1. And if we kind of came back, we'd see that crosses over 1, and of course the anaerobic threshold is here. That's the 1 would be when there's an increase in the CO2 that eclipses the O2. So there. And then let's see, we can see the crossover in panel 4. We even can see it in the plots, actually. If you'll notice, the greens are the CO2s, or the greens are the O2s, and we see it, they tend to rise underneath, and then they tend to eclipse over here. And then of course, if we wanted to, we can actually look for it in here, where we come to our, let's see if I can find it for you real quick, 24, 26, there it is right there, minute 7, it looks like. So minute 7 may start it. We see a 2611, and then we see under VCO2 27. So we see that. And we also see it in the previous one from 24 to 25, 2751 to 2796. So we can see it in the data sheet also. Okay, I just wanted you to be familiar with that, and we'll stop right. Okay, a few closing words about the anaerobic threshold. So as we evaluate the test, number 4 here was to evaluate whether the anaerobic threshold was reached, and we just covered that. But I do want to mention that, like in this test here, the anaerobic threshold really was never reached. But most of the test data in this is excellent, so it has great test data. This would be still considered a sub-maximal test. And a sub-maximal test means that we haven't pushed it all the way to their greatest effort they could give. So that obviously has to be determined patient by patient. The patients that we have that we are testing them for medical reasons, we're obviously very cautious on how far we can go. And a lot of them may have limitations, musculoskeletal limitations, or other limitations like that. So it is always in our best interest to try to reach an anaerobic threshold. But if we can't, and it's a submaximal test, the quality of the data can still be quite good, So if we kind of go back here and take a quick look at this particular test, this particular patient never reached an anaerobic threshold, and they could not reach an anaerobic threshold. They ran out of air, or they experienced severe shortness of breath and had to stop the test after about 5 minutes. They reached about 5 minutes. And you can see some of the dynamics here, which we'll talk about later. But they weren't able to get there. There were other reasons, medical reasons, why they couldn't reach an anaerobic threshold. And we see that too with our patients. So again, anaerobic threshold should definitely be the goal we aim for. But if we don't reach it, we may find the test data is still very good. And right now it's only weighted 1 point. So that's all I have to say about that, and we'll stop there.